All right, class, let's continue. So we are actually introducing other roots other than cube roots today. So it says examine the fourth root of a value to complete the following. Does the cube root of 16 equal the fourth root of 16? So if you haven't noticed already, this sheet I have actually also had the numbers to the fourth power as well, because it's important that we know these numbers. I actually even wrote numbers to the fifth power, just to have them on the side. Okay, but I hope this is obvious. No way, right? The cube root of something, 16, is totally different than the fourth root of 16. Okay. Explain in words how simplifying a whole number with a fourth root is different than simplifying a cube root. Simplifying a fourth root requires you to identify if a so we don't really have a word for a cube. Like a square is the name for squaring something, like multiplying by 2. A cube is the name for cubing something when you multiply something to the third power. We don't really have a name for anything beyond that, so I'm going to call it simplifying a fourth root requires you to identify if a fourth power, which is otherwise known as, the cube with one more, the fourth power, is a factor of the value under the root. You have to look at the perfect fours, for lack of a better way, the perfect fours. When you're finding the fourth root of something, you no longer care about the perfect squares. You no longer care about the perfect cubes. You have to look at the perfect fours. Now, the good news is you don't really have to know too many perfect fours, because as you go down the list, the number gets significantly larger and larger. So you don't have to worry too much. But you do know that the fourth root of 81 is a perfect 4. I'll call it a 4, and that might not be the best way to call it, but I call it a perfect 4 because it's kind of like saying a perfect cube. This is a perfect 4, which is 3. So explain why the fourth root of negative 81 has no solution. What? I thought it did. If it was the fourth root of 81, it would. But the fourth root of negative 81 has no solution, because if the cube root was an odd function and a square was an even function, well, then a fourth root also has to follow the rules of even functions, because a fourth root is an even function, and therefore the output should not be negative, cannot be negative, right? If you have something times itself, like something times itself 4 times, there's no way that if you multiply something by itself 4 times, it could ever be negative. Just like an even function, these are following the rules of even functions. There's no way that it could ever be negative. Okay, this is just like a little taste of the fourth root. And now we're going to go into. No, this is a little bit of a long lesson, but let's just talk about this. We have a last page. You know what? I'm only going to do maybe half of the last page, because the last page is just all practice. So I'm just going to talk about this, and I am going to show the last page, the final version of it. I'm going to show you basically what the answers are, but I don't think I have time via a video to describe all of the last page. So in this module, you have seen square roots, cubic roots, and fourth roots. But it is important to note that roots come in all sizes. If n is a positive integer and a is a real number, any real number whose nth power equals a is called an nth root, denoted as a nth root of a, denoted as nth root of a. So the fifth root of 96, you have to locate what value to the power of 5 is a factor of 96. Okay, this is where it gets a little challenging. Yeah, it's not the easiest for sure. But it's what value to the power of 5 is a factor of 96. So you look at your perfect fives. I wrote them down here. And the reason why this is easy is because 96 is a small number, and none of these numbers would ever work with 96. It's already way too big. So really, the question is, does 32 work with 96? And the answer is yes. So you'd say it's the fifth root of 32 times the fifth root of 3. 32 times 3 is 96, and we know that this is a perfect 5. So we know that this is going to be, now what is the fifth root of 32? What times itself 5 times would equal 32? The answer is 2. The number 2, and then it's 2 to the fifth root of 3. Okay, notice how I use that dot. Okay, now I do admit that this is, somewhat challenging. If this is too hard for you to understand right now, maybe it's good to pause and just practice the cube roots right now. Fifth roots and sixth roots right now is just maybe a little bit too out there, and you definitely will use this in the future, but it's not as common as a square root or a cube root, right? And that all deals with the fact that we use cube roots to deal with volume. I'm not really sure when you would use, we don't really use the sixth root that often, basically. But we just wanted to introduce this to you, that it is possible to find the sixth root of something. You know what? I'm actually going to stop right there, and I'm going to turn to the last page just to practice. Now, in the interest of time, I'm going to do this I'm going to do this in a normal speed. And if you feel like you want to pause, if you feel like, wow, this is too much, just pause. For this class, I think you have to be familiar with, just understand the square roots, the cube roots, maybe to try a 4 and a fifth root every now and then. But definitely want to try all the cube roots, okay? The roots that are higher is just mainly just talking about your concept. Do you understand how to handle a seventh root, right? Like the seventh root of -1, we know is just -1, because first, 7 is an odd function, so we know that it exists. Odd functions allow negative answers, so we know that it exists, and the seventh root of 1 is just 1, right? The fifth root of -32, again, we know that this is an odd function, so we know that the value under the root can be negative, and it's because this number is odd. And also, the fifth root of 32, well, 32 is a perfect 5, right? So 32 is a perfect 5. We know that the fifth root of -32 is actually just -2. Okay, -2 just times -2 times -2 times -2 times -2 is going to equal -32. Okay, scroll down all the way to number 20, you realize the 10th root is an even function, right? It's an even number, so it's an even function. Now, how do you find the 10th root of -1? Well, an even function cannot have a negative output, so this is not possible. So even functions cannot have a negative output, right? So this would not make sense. This is impossible. This is no solution. Okay, something like number 22. I'm just kind of rapid firing what I think are interesting questions. Something like number 22, whenever we had a value outside of the roots, that number, we always divided the power by that number. If you saw the how I did with the cube root, you realize I divided the power by 3. Well, in this case, you always divide by the root. You always divide each power by the root. Okay, so what's 12 divided by 6? That's 2. And then what's 18 divided by 6? That's 3. Okay. If you think about it, x squared n3, if I multiplied that 6 different times, you would get x2, x2. You get 6 of these, which gives you 12, and then you get 6 of these, which gives you 18. Okay, something like 23, and I'm just going to go fast. We're running a little bit out of time. When you have a fourth root and a fourth power, this becomes, they cancel each other out, right? These are exact opposites. You have a power and you have a root. The root and the power are opposites, are inverse operations. So effectively, they cancel entirely. So what you're left with is exactly 18n. These are the subtleties of this lesson. I realize I am going fast. It's just, this is basically one of the procedures of algebra you just have to be comfortable with. 24, we have the fifth root of 243. Now, again, I have a list right here. The fifth, 3 to the fifth power is 243. So it's really, really helpful, almost essential that you have the perfect 5s or the perfect 4s or the perfect 3s written down. You want to have them down, ready to go, because you want to know, is 243 even divisible by, or is 243 even a perfect 5? And in fact, it is. So then you get, I'll split this up into this. 243 times the fifth root of A8 times the fifth root of B15. Okay, so many, many interesting portions. So this is a perfect 5. We know that this is simply just 3. This is clean. Fifth root of b to the 15 is just b to the third. This, however, is an issue. We don't have a perfect amount here. So really, in 8 amounts of A, how many groups of 5 can we create? Now, we can only create one group. So one group was able to jump outside, and there still will be some left over on the inside. There will be 3 left over on the inside. Here, we made 3 groups of 5 to make 15 people, right? Here, if 8 people, we only can make one group cleanly, and there will be 3 people that are kind of stuck. That's how you should think about it when you're dividing or when you're finding the roots of a variable with a power, right? How many times does 5 go into 8? Well, 5 goes into 8 one time, and there's 3 remaining. So you have to write that under the roots. And then you have to combine all these things, and you get 3ab cubed times fifth root a3. Okay. I'm going to go ahead and finish the rest of this, but I will be posting the lesson notes on Google Classroom. And I think that's all for today. We learned about cube roots. Please study cube roots. That's one of the most important ones. Square roots. And then fourth and fifth roots and anything beyond that, be familiar with it. Try your best. And as always, please let me know if you have any questions, and I will gladly explain them with more detail in the future. Okay, class? Take care.